Download this code from codegive.com, link in the description below. OK, let's dive deep into deploying and using open source large language models, LLMs, using Runpod. This tutorial will cover everything from setting up a Runpod environment to running inference with different models. Table of Contents *. 1. Introduction to Runpod and LLMs. 2. Choosing an LLM. 3. Setting up a Runpod account and securing API key. 4. Creating a Runpod template. 5. Launching a Runpod instance. 6. Setting up your environment, SSH and Python. 7. Loading model weights and deploying the model. 8. Running inference, basic examples. 9. Advanced inference techniques. 10. Using APIs and serving the model. 11. Monitoring and managing your Runpod instance. 12. Conclusion. 1. Introduction to Runpod and LLMs. Runpod. Runpod is a cloud platform that provides GPU-powered virtual machines, pods, at competitive prices. It allows you to easily access and run machine learning workloads without managing your own hardware. It's a great choice for running LLMs because it simplifies the process of acquiring the necessary GPU resources. Large language models, LLMs. LLMs are deep learning models trained on vast amounts of text data. They can generate text, translate languages, write different kinds of creative content, and answer your questions in an informative way. Examples include models from the Llama family, Mistral family, Falcon, and many others. Running these models requires significant computational resources, GPU RAM, which makes platforms like Runpod very useful. 2. Choosing an LLM. The choice of LLM depends on your specific needs. Here are some popular open source options and considerations. Llama 2/Llama 3, Meta, a widely used family of models known for its performance and open source nature. Requires accepting Meta's licensing terms. Different sizes, 7B, 13B, 70B, 8B, etc., offer trade-offs between speed and accuracy. Great for conversational use cases. Mistral 7B *, a smaller, high-performance model. Excellent for tasks that don't require the sheer scale of larger models. Known for its efficiency and quality. Falcon, Technology Innovation Institute, available in various sizes. A good choice if you're looking for a capable model with an permissive open source license. Llama models. Many fine-tunes are available on Hugging Face. Quantization. Consider using quantized versions of LLMs, example using bits and bytes, to reduce GPU memory requirements. This allows you to run larger models on smaller GPUs, although it may slightly impact performance. The most common is 4-bit quantization. When choosing, think about task. What do you want the model to do? Chat, text generation, code generation, etc. Size. Bigger models generally perform better but require more GPU memory. License. Understand the licensing terms of the model. Hardware. Consider the GPU resources you have available on Runpod. For the sake of this tutorial, let's assume we'll deploy a quantized version of Llama 2-7B Chat HF, since this model is widely known, and can be deployed with consumer-level GPUs. 3. Setting up a Runpod account and obtaining API key. 1. Sign up. Create an account on the Runpod website, https://www.runpod.io/ https://www.runpod.io. 2. Add funds. Add funds to your account to cover the cost of running your pods. Runpod uses a pay-as-you-go model. 3. Retrieve API key asterisk. Go to the API keys section in your Runpod dashboard. Generate a new API key. Treat this key like a password. Do not share it. Save the API key securely. You'll need it later. 4. Creating a Runpod template. Runpod templates allow you to pre-configure your environment, making it easier to launch instances. This will greatly speed up your workflow. 1. Navigate to Templates in the Runpod dashboard, go to the Templates section. 2. Create a new template click Create Template. 3. Choose a base image For most LLM deployments, a good starting point is a pre-built Docker image with CUDA drivers and Python. I recommend using a Runpod verified template that comes with CUDA drivers. 4. Configure the template name give your template a descriptive name, example LLM inference template. Description add a description, example template for running LLMs with Python and CUDA. Docker start command this is the command that will be executed when your pod starts. You can leave this blank initially, as we'll handle installation and setup later. If you want, you can add a basic command to keep the container running such as tailf/dev/null. Docker entry point leave this blank. GPU driver install keep defaults for the driver installation. 5. Save the template click Save Template. 5. Launching a Runpod instance. 1. Navigate to Pods go to the Pods section in the Runpod dashboard. 2. Create a new pod click Create Pod. 3. Choose a template select the template you created in the previous step. 4. Select a GPU browse the available GPUs. Important choose a GPU with enough memory to load your model. For the Llama 2-7B Chat HF model, quantized, a GPU with 16 GB of VRAM should be sufficient, example an RTX 3070, RTX 3080, A100, etc. Larger models, example 70B, will require much more, 40 GB plus. Consider the cost per hour of the GPU. 5. Select storage choose the amount of storage you need. A few hundred GB is often enough. 6. Configure pod settings networking ensure that ports 22, SSH, and potentially others you'll use for serving the model are open. 7. Create the pod review your configuration and click Create Pod. Runpod will start provisioning your pod. This may take a few minutes. Once the pod is ready, you'll see its status change to running. 6. Setting up your environment, SSH and Python. 1. Get the pod's IP address in the Runpod dashboard, find the IP address of your running pod. 2. SSH into the pod open a terminal on your local machine. Use the following command to SSH into the pod. You may need to accept the SSH key fingerprint the first time you connect. 3. Install Python packages update the package lists. Install Python and pip. Upgrade pip. Install the necessary Python packages. Torch PyTorch, a popular deep learning framework. Transformers Hugging Faces Transformers library, essential for working with pre-trained LLMs. Accelerate Hugging Faces library for simplifying distributed training and inference. Very helpful for leveraging GPUs. Bits and bytes for quantization, running models in lower precision, like 4-bit. *PEFT, for parameter-efficient fine-tuning techniques, if you plan to fine-tune the model. 7. Loading model weights and deploying the model. Now, let's load the model weights and prepare the model for inference. 1. Create a Python script *, create a new Python file, example load_model.py, on your Runpod instance using Nano or Vim. 2. Add the following code *. 3. Run the script *, execute the script from your terminal. This will download the model weights from Hugging Face Hub and load the model into your GPU memory. The print statements will confirm if the model loaded correctly and which device is being used. Important notes ***. Quantization **. The code includes quantization to use less memory. If your GPU has enough VRAM, you can try removing the quantization _config to load the model in full precision, example torch_type equals torch.float16. This might give better results. Model selection *. Make sure to select the right model name based on your requirements. Hugging Face token *. If you are using a model that requires authentication on Hugging Face, example some of the meta models, you might need to authenticate using your Hugging Face token. 8. Running inference, basic examples. Now that the model is loaded, let's run some inference examples. 1. Create an inference script *. Create a new Python file, example inference.py, on your Runpod instance. 2. Add the following code *. 3. Run the inference script *. This will run the model with the provided prompts and print the generated text. 9. Advanced inference techniques. Temperature sampling *. The temperature parameter controls the randomness of the output. Higher temperatures, example 1.0, result in more random and creative text, while lower temperatures, example 0.2, produce more predictable and conservative text. Top P, nucleus, sampling *. Top _P filters the probability distribution of the next token, keeping only the most likely tokens that cumulatively add up to the top _P value. This helps to reduce gibberish and improve the quality of the generated text. Repetition penalty *. Repetition _penalty discourages the model from repeating the same tokens or phrases, which can lead to more coherent and diverse output. Beam search *. Beam search explores multiple possible sequences of tokens in parallel, keeping track of the most promising candidates. This can improve the quality of the output but is computationally more expensive. The number _beams parameter controls the number of beams. 10. Using APIs and serving the model. To make your LLM accessible to other applications, you can serve it using an API. Here's a simple example using Flask. 1. Install Flask *. 2. Create an API script, example appy. 3. Run the Flask app *. This will start a Flask server on port 5000. 4. Access the API *. From your local machine, you can send a POST request to the API using curl or Python's requests library. Replace your _pod_IP address with your pod's IP. Or with Python. 5. Open the port, if necessary. If you are getting connection refused errors, make sure that port 5000 is open in your Runpod pod's network settings. 11. Monitoring and managing your Runpod instance. Runpod dashboard *. Use the Runpod dashboard to monitor the CPU, GPU, and memory usage of your pod. SSH *. You can use SSH to monitor the system logs, check the status of your processes, and troubleshoot any issues. Use commands like top, and nvidiasme. Cost *. Keep an eye on your Runpod account balance and the hourly cost of your pod. Stop the pod when you're not using it to avoid unnecessary charges. 12. Conclusion. This tutorial has walked you through the process of deploying and using open source LLMs using Runpod. You learned how to set up a Runpod environment, load model weights, run inference, and serve the model using an API. By following these steps, you can leverage the power of LLMs in your own projects. Remember to explore different models, experiment with different inference techniques, and monitor your Runpod instance to optimize your costs and performance. Next steps fine-tuning explore fine-tuning LLMs on your own datasets using the PEFT library to tailor them to specific tasks. Distributed inference if you need to scale your inference capacity, investigate distributed inference techniques using libraries like Ray. Production deployment use more robust serving frameworks like FastAPI or Triton Inference Server for production deployments. Prompt engineering learn how to design effective prompts that elicit the best performance from your LLMs. Good luck, and happy LLMing!